Welcome to the Odd Jobs Workshop. It is possible to add a hobby-type servo to a CNC machine controlled by an Arduino and CNC Shield running grbl software. If all four stepper motor controls are in use, a servo can provide an additional axis of motion, or a servo can simplify the mechanical design. For example, some plotters use stepper motors for the X and Y axes, but use a servo for the Z axis to raise and lower the pen. To keep this video to a reasonable length, I'm directing it to folks with knowledge of Arduino, grbl software, and the CNC Shield hardware. If you don't understand some parts of the video, watch it again after your CNC project is farther along. If you don't know how hobby servos work, some parts of the video will be worth watching. But if you want to directly control a servo with an Arduino, this is not the best way to do it. Servo control is added by modifying and repurposing the pulse width modulation output, originally intended for variable spindle speed control of cutting tools like routers. As shown, confirm that variable spindle is enabled in the config.h file, and make the changes to the PWM mode in the CPU map.h file. Note that these files are from grbl version 1.1h. The settings may be in other files in older versions. The electrical connections from the CNC Shield to the servo are shown. The repurposing of the Z plus pin is explained in the config.h file. In the video, I'm powering the Arduino, CNC Shield, and servo with just the USB cable. A real-world application may need additional power. I'll be using this setup to demonstrate the control of a servo with grbl software and G-code. I've added a protractor image to the servo for reference. The Handtech oscilloscope probes are connected to the servo control line and the spindle direction pin. The Handtech displays on the iPad over Wi-Fi. The yellow trace is the servo control signal, and the blue trace is the spindle direction signal. The M3, M4, M5, and the S speed value command are the four spindle speed G code commands repurposed for servo controls. The four specific S commands apply to servos in general and the demo servo in particular. For the demo, I'm just typing the commands into the Arduino serial monitor on my iMac, but a G-code sender program can also be used. I'm going through a series of G-code commands to show how easy it is to control the servo with grbl. I'm starting by pressing the Arduino reset button, so grbl is in the lock state, with no control signal if servo turns freely. As usual, a $X command unlocks grbl. The M3 command enables the pulse width modulation output, and S55 sets the pulse width modulation to a 1 millisecond pulse. A 1 millisecond pulse is typical specified minimum pulse width for servos. The servo will no longer turn freely and will hold that position against force. If I type an S command of 118, the pulse goes to 2 milliseconds, which is a typical specified maximum pulse width. The 1 millisecond to 2 millisecond pulse range with S between 55 and 118 isn't a hard, fast rule. S40 and S149 will send my servo to its full range. Sending another S55 command sends the servo back to the exact same position as previous S55 commands. Servo commands are go-to position commands, not a stepper motor's move a distance commands. An M5 command disables the Arduino's pulse width modulation output, but the Arduino saves the pulse width value. Another M3 command re-enables the pulse width output with the saved pulse width value. The servo holds its position as long as there is a pulse. Sending M5 again stops the pulse and the servo is free to move, but sending the M3 re-enable command moves the servo back to position. An S command, while the output is disabled, saves a new pulse width value to be used when the pulse output is re-enabled. The command of S0 will also stop the pulses. I'm not sure which of these command combinations are useful. sending M5 again to disable the output, and M4 command to re-enable it. Just like the M3 command, the M4 command enables the pulse width output, but it also sets the spindle direction output high. M3 sets the spindle direction output low. The state of the spindle direction has no effect on the servo operation, and extra M3 and M4 commands don't have any effect on the servo, so the spindle direction could be used for something. It's easy to add a servo to a grbl based system and control it with G-code, but it isn't ideal. The minimum pulse width modulation available from the Arduino is 61 cycles per second. Using the measurement cursors on the oscilloscope, that's the F value in the upper left corner on the oscilloscope display. Hobby servos typically specify 50 cycles per second. The servo I'm using for this video works at 61 cycles per second, but other servos may not. At 61 cycles per second, the time period between the start of pulses is about 16.5 milliseconds. The T value on the oscilloscope. Think of the S command as a percentage times 10. An S command of 500 results in a pulse of half the period, about 8.25 milliseconds. The S commands of 55 and 118 result in pulses that are 5.5% and 11.8% of 16.5 milliseconds. They are approximately the 1 millisecond and 2 millisecond commands typically given as the maximum and minimum for servo. My servo has a greater pulse width range, but any S command less than 40 or greater than 149 causes the servo to strain against its mechanical stops. Use trial and error to determine the range of any servos you use. The S command range of 0 to 1000 would imply that the pulse width could change in 1000 steps, but that is not true. The Arduino pulse width circuitry uses an 8-bit counter, so it can only have 256 values. So there are only 256 possible pulse widths, and many of those are outside the range of the servos. Dividing 1000 by 256 gives 3.9, so most of the values between 0 and 1000 are in groups of 3 or 4 consecutive values. Any number in a group results in the same pulse width. For example, starting with S55, S56 changes the pulse width and moves the servo, but S57 does not, S58 does not, S59 does not. S60 does change the pulse and moves the servo. The servo speed can't be directly controlled, but a series of partial steps to the next position will have the effect of slowing the motion. So if you want to add a servo to your CNC project, I hope you find this useful. I have a few bonus tips to add. The servo I used in this video was a cheap one left over from a previous project, but servos are available in lots of variations. Check out servocity.com for servos and other mechanical hardware. I'm just a satisfied customer, they are not a sponsor. Pulse width modulation has lots of uses. It can control the brightness of a light, the speed of a motor, or the temperature of the heater. But pay attention to the frequency and voltage. The Arduino's 5-volt output might be too much for an LED without a current limiting resistor, and 5 volts certainly won't be enough to run a heater directly. You'll need additional circuitry. And the viewer might notice a light flashing with the 60 Hz frequency used for the servos. Here's some additional frequency settings for grbl CPU map.h file. For more accurate control of a servo, the Arduino has a pulse width modulation function that uses its 16-bit counter, but it may not be easy or even possible to use it with grbl. Check this link for more information on Arduinos and PWM. I hope this was useful. Thanks for watching.